Welcome to another video of the Organic Chemistry Lab series. In this video, we will talk about the synthesis of benzoic acid using the Haloform reaction. There are several ways to make benzoic acid, but in this specific case, we will talk about the synthesis of benzoic acid from acetophenone using the Haloform reaction. So, benzoic acid can be prepared from acetophenone via the Haloform reaction. This is the equation of the reaction starting from acetophenone, which is a methyl ketone. So we call it a methyl ketone because it's a ketone that has a CH3 group, and that's why we call it a methyl ketone using NaOCl, which is the bleach, NaOH, and heat. We will get the benzoate, which is the deprotonated carboxylic acid or the carboxylate, and the haloform. This is chloroform in this case because we have chlorine, chloroform. That's why we call the reaction haloform, because it always leads to the formation of a chloroform or bromoform or iodoform, which has the formula CHX3. This is called a haloform. And then once we add an acid, then the benzoate is converted into benzoic acid. So by just adding NaOCl and NaOH and heat, our product will be the benzoate or the carboxylate. And then after adding the acid, we can get the benzoic acid. So what is the haloform reaction? This is a reaction which is specific for methyl ketones. So if the ketone is not a methyl ketone, the reaction doesn't work. For example, this is, for example, is considered as a methyl ketone. Why? Because we have a CH3 group here. This is a methyl ketone. Whereas, let's say, for example, if we talked about this compound here, this is not a methyl ketone because we don't have a methyl group. We have a CH2 here and CH3 here. So again, if this is acetophenone, this is a methyl ketone because we have a CH3 group. So the haloform reaction only works if we have a methyl ketone. If there is no methyl ketone, then the reaction doesn't work. It doesn't give the desired products. This is an alpha halogenation reaction. What is an alpha halogenation reaction? So whenever you have an aldehyde or a ketone, this carbon which is here is called the alpha carbon. This alpha carbon has a highly acidic hydrogen, which is called the alpha hydrogen. Since this alpha hydrogen is highly acidic, in the presence of a base, we will see this in the mechanism, it can be easily removed or deprotonated. Now, once you have the anion, you can add different groups. You can add an alkyl group here, or you can add a halogen, and that's why the reaction is called an alpha halogenation, because in this example here we are going to halogenate or add a halogen such as chlorine or bromine or iodine to this alpha position. Usually this reaction is done using NaOCl, which is bleach, and NaOH and Cl2. NaOH and Cl2 will generate the required ClO minus and H2O, which are needed in this reaction here. Again, the reaction is called haloform because it produces CHX3, which is the haloform product. And in this specific reaction, once you start the reaction, you will notice that acetophenone will form, which is an oil. It will form an oily layer on top of the water reaction. So basically, once you add all the ingredients or all the constituents to this reaction, you will notice that there is an oil layer here. This is acetophenone, and then the bottom layer will contain the bleach and the NaOH. Now, as the reaction goes on, you should notice that the amount of this oily layer is decreasing and decreasing, and at some point this oily layer should completely disappear, and this indicates that the reaction is complete. Now let's talk about the haloform reaction mechanism. So starting from, this is acetophenone. This is a CH3. So in the presence of OH minus, it's going to deprotonate this, and this will lead to the formation of the minus here. So this is a conjugate base. I'm gonna leave it like this. Now this attacks the halogen, which is Cl2, and this leads to the formation of the first product. Now this step is repeated again. So again, OH minus attacks here. This gives an anion, which attacks another Cl2 molecule to give the product which has two chlorines. And if we repeat this one more time, we will get this intermediate. So if you repeat the same steps again, we will get the intermediate which has three chlorines. Now what happens is that when OH minus attacks here, and this goes up, we have a very good leaving group, which is this carbon connected to three chlorine. So this is a very good leaving group. So this O minus goes back and this leaves, leading to the formation of phenyl, C double bond OH plus C minus Cl3. So because of this CCl3 group, this is a good leaving group. OH minus attacks this carbon now. By the way, this carbon here, because of the withdrawing effect of those three chlorines, it's highly electrophilic carbon, so it has a much high amount of the partial positive charge, and that's why OH minus attacks here now when this leads to push the electrons toward oxygen. When the electrons go back, then CCl3 leaves. Now this is an acid, this is a base, so this attacks here and it abstracts the proton. And that's why in the first step of the reaction, we actually get the carboxylate plus the haloform. Now later on, when I add H+, I can get the benzoic acid or the carboxylic acid. So this is a mechanism of the haloform reaction. It's actually an alpha halogenation reaction, which is repeated 3 times. Once this intermediate is formed, OH minus attacks, and then CCl3 leaves, leading to the formation of the acid and the base, which exchange protons, giving the carboxylate and the haloform product. And after protonation, our product, which is benzoic acid, can be isolated or collected.